In this video, we will talk about radians as a measurement of angles. Well, so far, when we talk about angles, we have used the measurement of degrees because an angle, you can think about it just the openness between two rays. Like how open is the measurement between two rays? Well, so far we have said, 30 degrees, 45 degrees, 60 degrees, and so forth. So we have measured angles all in terms of degrees. But today, we're going to talk about a different way to still measure the same angles. And that is what we're going to refer to as a radian. So what exactly is a radian? Well, let's define it using the following idea. Well, a radian occurs whenever we have a circle. And in this circle, if we take a look at the measurement of this radius, if we were to measure that radius, whatever the measurement of that is, and we find some kind of an arc that still has the same measurement of that radius, so let's assume that this radius is 5 centimeters. If we measure this arc and it's also 5, then the angle that is created between those two is 1 radian. So a radian is the measurement whenever the length of the radius it's equivalent to the length of an arc. So the very basic definition, the definition is that a radian occurs when the radius is equal to the arc. And when I mean radius and arc or equality, I mean by length. So if I were to measure the length of the radius and I were to measure the length of this arc, they should be the same length. So whenever we have that the radius is equivalent to the arc, the angle that is being created by it's what we call 1 radian. So let's just put a formal definition to it. So what is a radian? Well, the radian is the angle that is created when the arc length of a circle is equal to the radius. So this is kind of like what we have said here previously, but we just want to put like a formal definition to it. So now that we know that this is exactly what we're going to refer to as radians, now the question is, how many of them, how many of these radians degrees do we actually have in a full circle? Well, there's one thing to remember, and that is that the circumference of the circle, remember that circumference, is equivalent to 2 pi r. So I know that if I want to have the actual measurement of the circle, that will always be equivalent to 2 pi times the radius. So now, how many radians do we actually get? Well, if the circumference is equivalent to 2 pi r, how many of this r do I actually have in a full circle? Well, this is saying that I should have 2 pi of them. So here we have 1 r, and notice that if I were to measure another arc length, let's assume that this is another arc length. Let's assume that they are still equivalent to the same value, which is r. So I know that if I travel another r, I have also created another radius. So here, notice that here we have 2 radius. And I know that if I travel another r, whatever r is in this case, I would have to create it another radian. And again, so if I travel another r, I should have created another radian. But how many of this r can I fit? This is saying that I can fit 2 pi of them, which remember that pi is about 3.14. So this is saying that I can fit approximately 6.28 of them. I can go and create 6.28 r. So 1, 2, 3, 4. This is 1, 2, 3, 4, 5. And now we got 6. And a little bit of an r, just a little piece of an r. So let's think about this for a second. I know that I can travel 6.28. I can fit about 6.28 of these r's in a full circle. So therefore, how many of those radians can I actually fit in a circle? Well, notice that for every r, I create one radius. For every r, I can create one radius. So if we use that idea, then how many of these angles can we actually fit in a complete circle? Well, that should be the same amount of r's that we were able to fit in the circumference of the circle. So the radians in a full circle, it's equivalent to 2 pi, which again, that's about 6.28 radians. But notice that this, it's an approximation. We want to always use exact values. So we're going to say that in a full circle, I can fit 2 pi of those radians. Now, is there any relationship between the radians and degrees? Well, I know that in a full circle, I can have either 360 degrees or 2 pi radians. So therefore, 360 degrees should be equivalent to 2 pi radians. And recall that 2 pi is just a number. So therefore, I can just divide this by 2 pi. And by doing this, what we have actually said now is that 1 radian it's equivalent to 360 over 2 pi, which this is approximately 57.29 degrees. So what we have said here is that 1 radian it's about 57.29 degrees. So if this is what 1 radian is equivalent to, then that is exactly what we can put here as an answer. So what is the value of 1 radian in terms of degrees? Well, we just said it. 1 radian, it's equivalent to approximately 57.29 degrees. And notice that for degrees, we use the little circle on top. That's just the unit that we have used. And then for radian, either we have to write down the actual word radian, or sometimes we just keep it as pi. But there is no unit symbol that we can use for radian. We either sometimes just keep it as a pi, or we have to write down explicitly the word radian. But now, I can see there's a typo. So since now we have two ways to measure angles, is there any relationship that we can see among those two? I already have this relationship. I know that 360 degrees is equivalent to 2 radians, but I can simplify this and just say that 180 degrees it's equivalent to pi radians. So in half a circle, either I have 180 degrees or I have pi radians. And if that is true, since 180 degrees is equivalent to pi radians, then if we divide it by pi, on both sides, Now we can see that also 1 radian it's equivalent to 180 over pi. And in addition of that, if I were to divide it by 180 instead of a pi, I would have that 1 degree is equal to pi over 180 radians. And these are two very important ideas that we're going to use throughout this lesson, because this is actually the relationship that we'll be using among degree and radians. 1 radian is always equivalent to 180 degrees over pi, and 1 degree it's always equivalent to pi over 180. So if there's a relationship between those two, then therefore we can convert between units. So to convert degree into radians, let me just separate this. So to convert the degree units into radians, all we got to do, we got to multiply the given degrees by pi over 180, because I know that 1 degree it's equivalent to pi over 180 radians. And the other way around, if I want to convert radians into degree, all we got to do is take a look at the radians that were given to us and just multiply by 180 over pi, because this is exactly the relationship that we have. 1 radian, it's equivalent to 180 over pi. So if we want to convert from radians to degrees, all we got to do is just multiply by 180 over pi. And this is very important, and this is actually the main idea for today. How do we go back and forward between those two units? But I wanted to spend some time giving you the idea as to why that is true. Everything is given to us by the definition of the radian. Let's actually do a couple of examples. So here we have the measurement of 60 degrees. So let's assume that we have an angle that is about 60 degrees. Can we convert that measurement into radians? Well, according to our conversion, to convert a degree into radians, all we got to do is multiply by pi over 180. So let's convert 60 degrees into radians. So we're going to get 60, and we're going to multiply by pi over 180. So if we multiply this, this will be equivalent to 60 pi over 180. But notice that 60 over 180 can be seen as 1/3. So therefore, I can just see this as pi over 3 radians. So 60 degrees, it's equivalent to pi over 3 radians. Let's do one more conversion. Again, let's take a look at 90 degrees. So let's say we have an openness of 90 degrees. We want to convert this just using radian measurement. All we got to do is we're going to take a look at the given degrees, and we're going to multiply this by the conversion factor, where again the conversion factor is pi over 180. So this is just equivalent to 90 pi over 180. But notice that 90 over 180 is equivalent to 1/2. So therefore, this is equivalent to pi over 2 radians. So there is two ways that we can measure this openness between those two arrays, either by saying 90 degrees or either by saying pi over 2 radians. So let's go the other way around. Let's just do two quick examples to go the other way around. Now we're given radian measurements. Now we want to convert this into degrees. According to our conversion factor, all we got to do to convert radians into degrees, we're going to be getting the radian measurement, and we're just going to multiply by 180 over pi. So let's get the radians that were given to us. pi over 6. Let me multiply by the conversion factor. Now, why is it, or what is one way for us to remember? Well, usually radians are given to us in pi. So if we wanted to convert into degrees, the pi should disappear. So therefore, I should multiply by a pi on the denominator. So that's at least one way that I can just memorize it. So in this case, the pi will cancel out. So now I have 180 over 6 degrees, which this is equivalent to just 30 degrees. Therefore, if I have an angle that has 30 degrees, this is equivalent to just pi over 6 radians. Let's just do one more example. So here, let's convert this radian into degrees. So here we have 3 pi over 4 radians. Let's measure this into degrees. So all we gotta do is by multiply by the conversion factor. That way, this will cancel out. And now I have the following. I have 3 times 180 over 4. And now this is equivalent to 540 over 4, which is nothing more than 135 degrees. So what this is saying is, if I have an angle and I open this angle exactly 135 degrees, give and take, this is also equivalent to just saying 3 pi over 4 radians. So these were just some ideas about how to properly go back and forward between degrees and radians. And one thing to also understand is how is it that we define a radian and how many radians can fit in a full circle. So this concludes our lesson for today.